In this video, we're going to look at how to use a ratio or a proportion to convert one measuring unit to another. So first, let's look at what a ratio is. So a ratio is a comparison of two numbers by division. As you can see, I have example 4 to 3. We can use the word 2, but we can also use the symbol, the colon sign, or we can just use a fraction symbol. So it's 4 to 3. So all of these are the same. And a proportion is a statement of equality between two ratios. So if we know what a ratio is, for example, the ratio of female students, the number of female students in the class to the number of male students in the class is 4 to 3. And that's a ratio. But it doesn't necessarily mean there are only 4 female students and 3 male students in class. For example, we could have 40 female students and 30 male students. Well, so the ratio of the number of female students to male students is 40 to 30. But we know as a fraction, we can simplify it by dividing both the numerator and denominator by 10. So that's going to give us 40 divided by 10, that's a 4, and 30 divided by 10, that's a 3. So that, and after we simplify 40 over 30, we should get 4 to 3. So that means they are equivalent. And as you can see, the left-hand side, it's a fraction, which is also a ratio. And the right-hand side is also a ratio. And notice they are equal to each other. That's what we call a proportion. So a proportion simply is two ratios, and they are equal to each other. Okay, and ratio has a very good property. Cross products are equal to each other. So for example, if we look at the left top, which is 40 times the right bottom, so and we get 4 times 30, that is 120. But if we look at the other product, the left bottom times the right top, which is 3 times 40, and notice that's also equal to 120. So that tells us the cross products, as you can see, that looks like a cross, they are equal to each other. So this is a good property which can be used to solve special equations like this. Okay, so first we're going to look at the applications of them and how to use them to convert different units. So we have two systems. In the United States, we use the English system. In most of the other countries, they use the metric system. So one thing we need to do is how do we convert from an English system to a metric system or metric system to the English system? And also, even in the English system, how do we convert, for example, from gallons to quarts or quarts to gallons, or liters to ounces or ounces to liters? So in order to do all these different conversion problems, we need to use either multiplication or division. But if you're not sure whether you should do multiplication or division, or which one times which one divided by which one, we can use a ratio or proportion to help us. So let's first look at this example. So given 1 liter equals 33.8 ounces, if you don't know that, you can just Google it, or you can find it from the textbook. And we need to find 24 liters equal to how many ounces? So we have two different solutions. The first solution, I'm going to use ratio to do it. And the second solution, I'm going to use a proportion to do it. And remember, a proportion is an equal sign, and the left-hand side is a ratio, and the right-hand side is a ratio. So a proportion has two ratios. A ratio equals a ratio, and there's an equal sign. But the first method, we also use ratio, but between these two ratios, we use a multiplication. So this symbol right here, a dot, means times. So this is the biggest difference between these two methods. And so make sure you stick to one of the methods you like, and make sure you don't mix up these two or confuse these two different methods. So the first method, we multiply two ratios. So the first ratio will come from the problem given. So for example, we're given 24 liters. So we write down 24 liters. And immediately, because we want to turn this 24 liters into a fraction, so we're going to put one underneath. So the bottom here, I'm going to put a 1 here. And so this is our first ratio. And then times, we're going to multiply by another ratio. And the second ratio will come from the given relationship. So what's the relationship between liters and ounces? And so we found this in the chart. And we are going to use the left hand side and the right hand side, because a ratio looks like a fraction. It has a top and a bottom. So we're going to make one of them the top, our top, and the other our bottom. Now, which one is going to be the top or which one is going to be the bottom really matters. So the thing here is we are going to want to match the top. So for example, in the first ratio, we have a numerator which has liter in there, the measuring unit liter in there. So we want to make sure in the bottom in the second ratio, so let me label this. So this is our first ratio. In the second ratio, we want to make sure, again, the second ratio consists of the left side and the right hand side. So we're going to take the one with the liter and put it in the 1 liter in the denominator, and put the other one in the numerator. So why do we how do I know I should put 1 liter as our denominator? It's because a rule, because now ratio, we can consider them as fractions. And notice that when we multiply fractions, and we multiply straight across, so it's going to be the top times top, bottom times bottom. And before we multiply them, we can also reduce. So any top number can reduce the bottom. Similarly, the top liter divided by the bottom liter, so it's kind of like they're canceled. So liter divided by liter, we cancel them. And now what we have left will be the top. So now we can multiply straight across. So the top there's a 24, and notice that liters, this has been canceled. Now times 33.8 and the ounce. The bottom, we have the denominator 1 times 1, but we can kind of put a 1 times 1 here. But notice that 1 times 1 will still be 1. So the bottom will still be 1. Or you can go ahead and just get rid of it, because anything divided by 1 will be the self. So we can just work out the top. So let's work out 24 times 33.8. So we can set up, we just talked about how to multiply decimals. So I'm going to write down 33.8 times 24. And so to multiply decimals, we first ignore the decimal point. So we pretend this decimal point is not here. So we just multiply 338 times 24. So first we multiply 4 with, so focus on 4. We do 4 times 8, that's 32. You can use the times table if you don't know that. And then 3 times 4, that's 12. But we're going to add the 3 to 12. That gives us 15. And then 3 times 4 is 12 plus 1, that would be 13. Now when we're done with 4, we're going to multiply 2. So, but this 2 means 20. So immediately we put a 0. This 0 comes from 20. So we're going to do 2 times 8 and 2 times 3. 8, we have a little 1 there. So 2 times 3, 6. 6 plus 1, 7. 2 times 3, 6. Now we're going to add vertically. So 5 plus 6 is 11. So 3 plus 7 plus 1 is 11. 6 plus 1 and 1, that's 8. So when we get the answer, we're going to put the decimal point back. Notice 24 doesn't have any decimal places here. So 33.8, there's one decimal place to the right of the decimal point. So in the final answer, we're just going to put the decimal point right here. So we have one decimal place to the right of the decimal point. So the answer at the top is 811.2, and the ounce will still be there. And again, anything divided by 1, it will be the sub. So we can just get rid of the bottom. And that's the answer. So in this solution, we use the two ratios, but between the two ratios, it's multiplication. So literally, we are multiplying. It's kind of like we multiply with two fractions. And because when we multiply fractions, we multiply straight across, but we can reduce what the common number or variable. So the liter and liter, these two measuring units can be canceled. So now we successfully turned liters to ounces. So as you can see, we started with liters, but now in the answer we have ounces because we cancel the liters. Okay, so now let's look at a different method. And we still have two ratio, but so the first ratio and the second ratio between them, it's gonna be an equal sign, not a multiplication sign like we did. So when we set up, it's gonna be totally different. So we're gonna have to line up the same units. So here, when we did the multiplication, because in order to cancel the liter, convert liter to ounce, we have to cancel the liter. So that if the liter is in the top, you have to have a liter in the bottom so they can cancel each other. Because the multiplication procedure we're doing. But for proportion, we have to make sure we line up. For example, 24 liters, and again, we're still going to use the other conversion relation here. So you either have two options, whether you either put the 1 liter in as the numerator of the second ratio or as the denominator. So for the first one, you have two options. I'm going to show you both options here. And you can put 1 liter here. So either line up the liter horizontally or vertically. Now, in the first case, 1 liter, so let's write down 1 liter corresponds to 33.8 ounces. So you can go ahead and line up, make sure you put 33.8 ounces on the same side with the liter because they are equal to each other. Now, how many liters are going to correspond to 24 liters? That's the question. So we're going to put a question mark here, or we use a variable x. And so we got a proportion. So let me just get rid of all the units because liter and liter, they cancel each other, ounce and ounce. So we just get 24 over x equals 1 over 33.8. And then we can use the property we just talked about of when you have a proportion, the cross products are going to be equal to each other. So we're going to cross multiply. X times 1 equals 24 times 33.8. And x times 1 will still be x, 24 times 33.8, which I already did here. So we can bring down the answer. So x, 811.2 ounces will correspond to 24 liters. Now, the other way that I mentioned when you set up the proportion, you could line up liters vertically. But if you line them up vertically, on the right-hand side, again, 1 liter corresponds to 33.8. So make sure you line up 33.8 ounces horizontally with 1 liter because they correspond to each other. So 24 liters correspond to how many ounces? And that's going to be a question mark. We use x. So that way, again, liters cancel liter, ounces cancel ounce. So you still end up with a similar equation, proportion. So again, a ratio equals another ratio. So we can do cross multiply. So 1 times x equals 24 times 33.8. So cross products are equal to each other. So we still get 1 times x is x, 24 times 33.8 is still 811.2. So either way, you can get the same answer. So let's quickly look at another example here. So 60 foot per second equals how many miles per second? Notice they're both per second and second, so we don't really have to do any conversion here. But we do need to convert a 60 foot to how many miles. So first, from the chart, we found the conversion relationship between them. 1 mile equals 5,280 foot. So let's, again, there are two options. If you can use a ratio times a ratio, ratio times ratio, or you can use a ratio equals another ratio, which is a proportion. Okay, so the first method, you start with whatever they gave you. So they gave me 60 foot. So I'm going to write it down. And I put a 1 underneath to turn that into a ratio or fraction. Now, for the other second ratio, we're going to use this. And remember, in this, since we're doing multiplication of fractions, we want to make sure this foot is going to cancel another foot down here. So we're going to make sure we put the side with the foot, so which is 5,280 foot in the denominator, so they can cancel each other. Top foot cancels bottom foot. So, and we're going to put 1 mile in the numerator. So now we can multiply straight across to get the answer. So we have 60 times 1 straight across, top times top, and the mile, over 1 times 5,280, and the foot is canceled. So now we do 60 divided by 5,280 and the miles. So here we have to do a division, a long division. So you divide both top and bottom by 10 to reduce this a little bit. And then you do 6 divided by, so now it's equivalent to 6 divided 528. So I'm going to skip the lump division process and go ahead and give you the answer. What you have to do, follow what we learned before, and you have to set up a lump division to divide this way. And the answer is about 0.0113 miles. Okay, so this is the first method. The second method, we use the proportion, a ratio equals a ratio. So first, we're gonna write down. Well, we could start with this one. You can go ahead and just put 1 on the top, 1 on the bottom, any way you like. But once you put this down, and you have to make sure the information given, 60 foot, has to be lined up with the foot. So because so they're gonna be lined up instead of top and bottom, so they can be canceled. Again, the difference is because we're doing multiplication, top and bottom cancel each other. But when we do set up a proportion, we have to make sure they're lined up. That way they can be canceled. So how many miles? It's unknown, so I'm going to use X. Again, once you get that, mile cancels mile, foot cancels foot. The reason is it's not a multiplication sign between them. They're on both sides, so they can be canceled. And you can think of this as divide both sides by mile and a mile. So they cancel each other. Divide both sides by foot and foot at the bottom, so they cancel each other. But we are going to end up with 1 over 5,280 x over 60. So now we're going to cross multiply. 5,280 times x equals 1 times 60. So now 1 times 60 is still 60. So in order to get rid of 5,280, we divide both sides by 5,280. So now we're going to get 60 divided by this, and which I'm just going to copy my answer from here, miles. So either way, it works.